So one thing I said last time is that if you wish, obviously it is not mandatory, but since I happen to give a course of about the fundamentals of programming to the bachelor degree in management engineering, if you want, you can take a look at this, simply because it is more structured like a course, so you have some more explanations, okay? So you can find it easily on Moodle. Just beware that it is a course that is at the first year of the bachelor degree in management engineering, so ingegneria gestionale in Italian. First year, second semester. Beware that the course is split in two. So my part is LZ, okay? The AK part is another professor. The contents are similar, but I cannot guarantee they are completely equal, and obviously they are arranged different. So why I'm mentioning this, because obviously some of you who is more new to programming may find it a bit more easy to actually have more explanations and more examples. And also because I know, since I created this course, that there is not too much here, okay? It's right enough for a start with Python. You have the basics of Python, which is basically what we said in this course very quickly. You have some additional information about functions. You have the basic data structures like lists and dictionaries that we already seen. The only thing that I would say we didn't cover, but for sure it makes no harm, is a bit of object-oriented programming, but this is just really a bit. I think it's like 10 slides. And handling files. That's the only thing that we don't cover actually in this overview, but obviously this is a whole course. It is not a big course, it is 6 credits, but you don't need to take this course, obviously. But if you want to clarify something, for instance, that could be a good place where to look for. So since we have time, let's do a recap of what we did. So for instance, first thing that we have seen is Python data types. So primitive types, numbers, booleans, whatever. Then we started playing with lists, first structured data type, in which we can put collections of data, of values. And lists can be mutable, so you can change elements in lists, you can add and remove elements. So I added some comments offline to make it easier to understand. You can arbitrarily nest lists, and we have seen that this is a way in which we can obtain the matrix data structure in Python. Today we will see that NumPy offers a much more convenient way to have multidimensional data structures. So if I want a vector, if I want a matrix, if I want a tensor, that is simply a multidimensional data structure with more than 2 dimensions. So the matrix is a special case of a tensor. NumPy is much better. Okay, it's quicker, it's more efficient, and you can also do more difficult stuff with less effort. Then we have seen the tuples, which are between not square brackets like the list, but between normal parentheses, round brackets. Tuples are similar to lists in the sense that they can contain a collection of values, and the values are ordered, so we can use this sort of positional notation to access the element in a specific position, but tuples cannot be changed, mutated. So if a tuple is created with 3 elements, the tuple cannot be added an element, cannot be removed an element, and any of the element that is in the tuple cannot be changed to another value. Then we have seen dictionaries, which are these sorts of grouping of elements. It is again a collection of values, but not individual values. It is a collection of key value pairs. And the main reason to have these 2 different data structures is that lists are convenient either if you know that the majority of the operations you will do on the data structure will be simply to iterate the data structure to look for something, or if you know that most of the time you will get specific elements because you know the position. Instead, if you want to put elements in a data structure and you know that the majority of the times in which you will need to access a specific element, you don't know the position, but you want to have a mnemonic label to refer to the element, a dictionary is far a better solution. Dictionaries can also be used for another purpose, that is grouping together elements. We can nest dictionaries one into each other, as we did for the lists, and in this way you can have groupings. So for instance, the name of the data structure dictionary is not by chance. This is actually how you would implement an actual dictionary. Okay, you start with letter A as a key, and then probably a list of all the words starting with A. This list of words can actually be organized not as a list, but as another dictionary with many keys: AEA, AB, AC. And as a value of this, all of the words that start with AEA, AB, AC. Let's make an example to clarify, because this toy example is not really clarifying. The name of a dictionary is because it is the best data structure to create something like this. So let's say my simple dic. And what can I create? I can create something like all the words that begin with A. I don't know, abacus, abracadabra, whatever. Then all the words that start with B. Battle, okay, and so on. Obviously, this is probably not enough. So we can probably add another level in our dictionary. What do I mean with another level? I can associate to the key A, not a list, but another dictionary. Why would I want to associate another dictionary? Because I could do something like this. All the words that start with AA. All the words that start with AB. And so on and so forth. Obviously, I can iterate the reasoning again. If I wish, I can go to the third level of nesting. AAA, ABA, I don't know. Okay, so this is the biggest use case for dictionaries. When you want to create a data structure grouping items in some sort of way, okay, the dictionary could be a good choice. Achieving this with a list it is not very difficult to build, but it is very inconvenient to look into it afterwards. Because what could I do with a list is creating other lists. So here there will be, I don't know, all the A words. So abacus, abracadabra, and then with B, and so on and so forth. Now, if I want to add one level of nesting, it becomes even more messy, because I have to do something like this. So here, maybe I will put all the words with a something, okay? And then AB something, and then AC something. Okay, maybe not really difficult to build, but now looking for words here is a mess. Because I can't simply say give me all the words that start with A, and and there the words that start with AC or AB. That's very easy. First, I filter only the words starting with A. The value associated with this key is a dictionary itself. So again, I can use the direct access and get access to all the words with AB. In a list, I cannot do this. I would have to remember where are the words. So I had to remember to do the same thing. I would have to remember that actually the first list is the one with all the words with A, starting with A. And within that list, the second list is the one with words starting with AB. I would argue, but probably any of you would argue, that for a human being, this is far easier to remember than this.
So is it possible to recall A words from my simple dictionary directly going through A words?
No.
Without
No.
specifying the two?
No. So I repeat the question for the recording. Is it possible to get directly basically to AB words without going through A? Right, that was the question. No, simply because you must always refer to the variable you are working with. This variable does not have any AB key. So this will give an error. If we try to execute this, and we can quickly do it, let's comment, not like this. Let's try to comment all together if it works. No. So let's do this. Oh no, let's do better. Let's do this. So here is my dictionary. Let's try to complete it. No, actually we don't care. So here this should be fine. Not here. Okay, this should be the correct way. Let's do this. BA. Just to make it seem more correct, if you want. Okay, this should be it. For instance, if I want to access, so let's print our dictionary so we can see what it looks like. My simple dict. First time you execute in any cell in a Google Colab, it takes a while, because Google Colab, the server needs to initialize the Python environment and whatever. Second and subsequent times, it's almost instantaneous. So now, if you can see, this is actually the dictionary that we created. That in this way is not very easy to navigate. That's why I formatted it in this way. But what you can see is that there is no KAB, simply because, hello, welcome. Simply because in my dictionary, the keys are this. So for instance, if I want to quickly see the keys, I can do this. So my variable that source a dictionary, ask for the keys and put them in a list. These are the keys of the dictionary. I agree that also AA, AB, and BA are keys, but not of this dictionary. Of a dictionary within this dictionary. Okay, so that's the catch. So that's why you need to, in a sense, traverse your dictionary to actually have what you're looking for. So now we navigated our first dictionary. We pick the A key, and corresponding to the A key, there is a dictionary which has the AB key. This time the AB key has an empty list as a value, but this time it works. This instead wouldn't work. AB key in outer dictionary. And again, if for any reason you want to understand better some of the things, there is a nice tool that I actually use in my course, that is Python Tutor, which is a sort of debugger. But it's nice because it gives you a visual representation of what's going on behind the scenes. So let's turn off all this garbage. So this is maybe if you notice some weird behavior and you want to know more, you can go to this Python tutor, select a version, whatever version of Python should be fine. You can copy paste your Python code here, and you can see what happens and how what happens when you execute code and how the data structures are actually memorized in Python. So, for instance, when you visualize your code, you can execute it step by step, which is something that we don't usually do. So for instance, we are now creating our dictionary, and as you can see, lots of steps in which we don't see actually anything, but because this is one statement only, basically. Even if I put it on multiple lines, it's only one statement, so one assignment operation. When it's finished, this is actually the data structure that is in Python. That's a variable that refers to an object in memory, which is a dictionary with two keys. Each key points to another object, which is another dictionary. Okay? And so, for instance, if I put something here, I can edit the code. Maybe here is AB, and maybe here is BAB. Yeah, something like that. That will be the content. Okay. These arrows, if you come from C, should be familiar. This is more or less what a pointer is. That in C is quite a nightmare to handle pointers. In Python, there is no nightmare, basically. But you have this notion of pointers, which are not called pointers, but references. You have these references in Java, in C++, in C#, in any object-oriented language. So this should be quite familiar. And this actually gives you an immediate understanding about how doing this instruction, the one with the red arrow, does not work. Because we are looking for k, a, b in variable mySimpleDict. But variable mySimpleDict refers to a dictionary that doesn't have k, a, b's. And so we get an error. Key error AB. In some sense, Python tutor may help you because it gives you actually the path to follow to get to one specific data structure. So if we want to get to AB, we need to do, first we need to traverse my simple dict of A, and then get access to AB.
Will it help us with the libraries as well, Professor?
Sorry?
The library functions, will it help us to visualize those as well?
Yeah, to some extent. You can visualize that a library object is called, so it's put here in these frames. And then you can see that the variables that are defined in a function, for instance, belong to a different space. And yes, it can also help to visualize that sort of stuff. It is mostly done for visualizing data structures and step-by-step execution, but it gives you a fair support also for functions. And so, for instance, what I wanted to show you at last, if I want to do something like avoiding this double, let's say, access notation, I can simply use another variable to store intermediate results. So, for instance, I could say my inner dict, that is my simple dict of A, and then now I can say my inner dict of AB. So this is the first way. So we need to navigate the whole data structure, let's say. So we are saying from my simple dict, let's take path A and then path AB, and then we get to this gibberish. And if for any reason I don't want to have this double access, I can use an intermediate variable. So I can put in my inner dict, let's see what happens when I execute this line of code, the one with the red arrow. Red arrow means next execution, next statement to be executed. Another variable pops up, okay, which, pay attention, doesn't create a new data structure. It simply refers to an existing one. This is one possible source of problems, of issues when you are programming, this sort of pointers of references. And in this way, with my inner dict, I can immediately refer to AB, because my inner dict is immediately a reference to the inner dictionary of my farmer variable. So now, if I do print my inner dict, not my simple dict, AB, I get no errors and I get to the same result. Okay. So this website can be nice to understand some basics. So that was to clarify the main differences between the use cases for using a list or for using a dictionary. Then we have seen a bit of control statements, not too much, only if and for loops. In Python you also have the while loop, in which you can put an arbitrary condition instead of iterating something. So here we have seen the for loop only for iterating lists. We can also have the for loop for iterating a number of times. In this case is something like this, and I choose the number of times I want to iterate. So this kind of for loop, which is combined with function range. Range is a function that simply generates a number of numbers, okay? Simply is, most of the time, it is used to simply do the same thing a fixed amount of times, usually. And you can also have a while loop when you don't have any of these two situations. I don't have any data structure to iterate, and I don't know beforehand how many iterations I want to do. but maybe I need to loop based on a certain condition. Okay, let's assume I want to loop until the user writes quit to quit the program. So what I can do is do this and then prompt the user this way. Input is a function that waits for user input. Sorry, this. So if I execute this code, as you can see, let me enlarge a bit. Is it fine also like this? Yes. The first line gets executed, so the Boolean value false is put into variable quit. I'm asking to do something while not quit. Not simply inverts a Boolean value, so this becomes true. So while true, okay, this is the condition that I want to check, so true the condition. So I enter in the while loop, and I'm asking the question, do you want to quit? No. Okay, bye. Why it works this way? Well, because we want to, this variable, I put there a string, not a Boolean. And if I verify a string, as long as the string is not empty, it means true. Okay? So beware of the data types you are using. What we can do is if reply is quit, then quit must be true. Okay? Let's try again. Do you want to quit? No. Do you want to quit? No. No. Random gibberish, number, whatever, until I hit quit. Okay? So the while statement is to be used when you don't know in advance how many iterations you need to make. Then we have quickly seen methods, the difference between methods and functions, because sometimes we use some sort of function by using a variable, a dot, and the name of the function. And instead, sometimes we simply use a function as it is, like print, like range, input. Okay? These are all functions that we can call without any variable, without any dot notation. Okay? So why? And we have seen that the difference is that a method can only be called, can only be invoked on a variable with the correct type. So, for instance, method sort works with lists. So, if within my list there is a list, this will work. And doesn't work with dictionaries. So, if within my map there is a dictionary, this won't work. Okay? In Python, we don't have to explicit the type of one variable. We can have variable x, put a number in it, and then afterwards put a string in it. It's fine. The variable is the type of the content of the variable. If you have a list in a variable, whatever the name, I can call a variable myList and put a string in it. I'm a bad person, but Python won't complain. Okay? And functions instead must be defined if we want our own function, or can be library functions. They simply provide you a functionality that is always available. You don't need a specific variable. Maybe you need a specific variable as an input to the function, but you don't need to invoke the function on a specific variable. And again, if you want to see how this may work, for instance, in Python tutor, you can. There is some sort of support here. So, look that the first instruction here is actually the definition of the function, not its invocation, so not its execution. Nothing is executed here. The only thing that executed is Python becoming aware that from now on, a new function named show fancy matrix is available. That's it. Then I create a matrix object. Okay. And let's do this. Show fancy matrix. Yeah, don't care. If I now execute the function, we can actually see what happens. So this new thing, a frame, gets created. This simply means a context for new variables. Here there is variable m, a new variable, which is the parameter of the function, and what has been put into that variable. Actually, the m variable as a reference to the exact same place where the matrix variable was. This is passing parameters. And then I can simply visualize the matrix by executing this function. So that's the kind of support you have when working with functions. But you at least can clarify something about passing parameters, which that sometimes may be not completely clear. Then we have seen modules, and then we started with pandas. With pandas, what did we do? First of all, pandas was the first library that we used that was not included in the Python standard library. So actually, to make it work, you have to do some magic. If I try to use pandas without doing anything, I get an error. I don't know what name PD is. Okay, so we said that if we want to use some functionality, like we have seen probably something like the math module or the random module, we have to first import the module, which means we need to declare that we want to use that additional functionalities. These modules, and many others, are already part of the Python standard library, which means that when you download Python and install Python in your machine, you automatically also download and install the Python standard library. So they are already available in your machine. You just need to declare that you want to use them. Here in the Google Colab is the same. The server that executes our code already has the Python standard library. And so, if you do something like this, it simply works.
So what's the difference between a module and a package?
It's simply a different way to organize. A package is the root, and it can be further subdivided into modules. That's the difference. But many times, the terms module and package are mostly interchangeable. With pandas, okay, so to fix this error, I simply need to import the pandas library. And the novelty is that with this particular keyword, we can give an alias to a library. For instance, if it has a long name, we can give it a shorter name. Okay, fine. Now it worked. But on your machine, you actually should first download and install the library, because pandas library is not included in the Python standard library. If we want to use NumPy, for instance, we have to do the same. NumPy is not installed by default in the Python standard library. So if you download Python for your machine, you should first of all install the library. And in Python, we can do something much more convenient, that open a web browser, go to the library web page, download manually the library, understand where to put the library to make it available to our Python code, we can use this tool, which is called pip. This is a command line tool, so you must open a command line like the Windows PowerShell or the Windows command prompt on the Linux terminal or the macOS terminal, and give this command pip, which is the name of the tool, install because you want to download and install a package, and the name of the package. The pip tool should be already installed when you install Python on your machine, so you don't need any extra install. You shouldn't need any extra install. Now that we installed actually the tool, here it works anyway because in the Google server it is already installed at Pandas. Now that we imported the library, the code works. Okay, so there is an additional step. When you work with external libraries, not in the Python standard library, it is not enough to import the library because you don't have the library yet. You need to download and install it. So then we started playing with Pandas, and Pandas basically give us two data structures, series and data frame. And a series can be created in many ways, from lists, okay? Usually from lists, you create a series. There are other ways, but usually you create a series from lists. And what kind of object is a list? A series, sorry. Well, actually it's not so different conceptually from a list, from a Python list. But if you can see, you have an additional thing. You don't only have the values that we specified while creating the series. We also have another series of values, which is called the index. The index is simply how to refer to that specific value. It's like the position in a list is the same. Where it differs because with a series we can have our custom index. So in the second series, I don't want a numerical index, which is the default. So if I do not specify anything, the index is numerical. Here I wanted a string index. And so I had to create the series by specifying what kind of index to be used. So you have this additional flexibility with the series. That's it. That's the only thing you can do with a series. These are additional ways you can build a series. If I give a dictionary as the argument of a series, the key becomes the index. So for instance, here I want to keep track, I don't know, of the size of planets, okay? So I want to use the planet as an index because there will be no two planets with the same name. And as the value, the dimension, the size of the planet, okay? And this is the resulting series. So series are just lists with a custom index? No. They are useful because with a series you can do operations in a more efficient way. This is called operation spreading. For instance, with a list, here is our planet size lists. So let's create actually the list. With this operation, we can divide each entry in the series by 100, and it works. So we got our original series. Every element has been divided by 100. This is very convenient because with a list you cannot do this. This gives an error for a list. I can't. The only way I have to do this with a list is to iterate each element and save each element in the same list or in another list, but I cannot do this quick operation in this way. This is called operation spreading, and this is actually the true reason for using series over lists. Then there is another reason. You can quickly filter elements with a series. Let's assume I have this series of elements. Okay, people used as index and a number associated to them. Let's say that these people owe me money. I can quickly filter my series, my list of elements, my collection of elements, using what is usually called a mask. So I can say my mask is that I want to filter only people that owes me more than 10 euros. So I actually do a weird thing, depending on which kind of programming language do you know. I am putting in a variable a comparison operator. That's weird. That's a bit weird. But actually this is not a comparison operator. This operator is actually defined for series, and so actually this is itself a series. In fact, if we print credit 10, this is what we got. So let's take a moment to check what's happening here. We have our series that is called credit, which is this series. Ali 45.3, Marco 10, Elia 17.5. That's our series. When we put into credit a variable called credit 10, this sort of comparison operator, in truth, we are already executing an operation on the series. We are actually saying what are the elements whose value is above 10, and in fact, the data structure that we actually have in variable credit 10 is another series with the same index, but the values are no longer numerical values, are Boolean values, depending on whether that specific original value satisfied the condition or not. So, since Ali in the original dataset was associated with a value of 45.3, now the value is true, because it's true that 45.3 is greater than 10. The opposite holds for Marco, because Marco exactly had 10, and instead the same holds for Elia, because Elia had 17.5. And now the most useful thing is that we can use this data structure as a mask to filter out our original series. So if we want to filter and let survive only people that owe us more than 10 euros, we can simply access our original data structure, not by saying, give me Ali, give me Elia, give me whatever, but give me all the rows in the series that satisfy this condition. Basically, give me all the rows for which this value is true. And in fact, by printing this kind of filtering result, we get that Marco is removed from the series. Okay? Obviously, we are not forced to do this in, let's say, in 2 steps. We can also do this immediately in 1 step. So we can do something like beware okay. We can simply do this in 1 step. It's the same. We simply avoided using an intermediate variable. And this time I filtered again Marco. So this is actually the most relevant, these two, so operation spreading and filtering with masks are the 2 main use cases for using series over lists. They are lists on steroids, if you wish. You can do more with a series than you can do with a simple list. Then we have seen how to handle missing data. That is relevant because when you are doing this sort of operation with series, something weird may happen. Let's check this example. Let's assume you are keeping track in different series objects about every day, every week, how many money people owe you. So let's say first day, Ali owes me 10, Marco owes me 5, Elia owes me 15. Second day, Sarah owes me 7, Marco owes me 5, Paolo owes me 33, and whatever. Now what do I want to do? Now I want to have a global view. Okay, but all the people that I encounter every day up to now, how many money do they owe me? How much money do they owe me? So I can simply try to naively do a plus, a summation over the two series. This doesn't work. We get this weird result. What is NaN? NaN is not a number, so it means I don't know what to put here. Basically, it's empty. Okay, it's an empty cell in our database. I don't have this data. Why? Well, because when you're doing this operation, Pandas tries to match the indexes, and only if he finds a match, he does the operation. So, since Ali does not appear in the second series, there is no match. So the operation fails, basically. The same for Elia, the same for Paolo, the same for Sarah. The only one here, actually, that has a match in the index in both series is Marco. So for Marco, the operation works. So, first of all, we can ask ourselves, okay, in the general case in which we have missing values in our dataset, that in the real world it often happens, how can we handle missing data? Well, there are two very easy ways. One is to simply drop, so remove any row in your series that has missing data. So for instance, if we use this method drop NA in our credit total series, we only get one element to survive. Then another strategy is not to drop the rows, but to fill the rows with a fixed number. In this case, I don't know if I don't have information, I assume that information is there. So I use this method fill NA to fill the dataset, and now NA values have been substituted with 0. Obviously, what to choose really depends on the situation, and there are many situations in which neither of these choices seem reasonable. Okay, so actually Pandas give you many ways to fill, to replace missing values. And if you do, for instance, a quick search, always prefer the actual documentation. Okay, you can find many tutorials. Okay, nothing wrong in general, but always prefer the actual documentation. You can find all the ways in which you can handle missing data. So for instance, value considered missing. Okay, inserting missing data. You can have what? Let's check. Ecco, filling missing data. That's it. So you can choose a value, fill NA. You can fill gaps by taking the last value. Okay, here the first value is 1, then you have 2 NAs. If you use method ffill, you take the former value and you bring it along. 1, 1. Backwards instead does the opposite, takes the first value after the missing ones and propagates backward. Okay, so you have many ways to do filling. Usually the best option for real use cases is not to use filling, because how can I choose one value to fill a missing value? So probably the best thing to do is to use the interpolate method. This is a much more sophisticated method, is a different method, and you have many different interpolation methods. So actually, the way that this method works is that depending on the method you are using, it looks at all the non-missing values you have and tries to do some interpolation. So for instance, you can use average, for instance. Okay, so look at all the values you have and fill the missing data with the average value of the values you have. Or interpolate using some linear interpolator or some other means. So this is actually the will be the correct way to do in the real world, choosing the method depending on your specific use case. Okay, don't be afraid to check into the documentation because it is very well done. Okay, it is very well explained. You have many examples also, so don't be afraid. And so actually, how can we okay, fine, nice, but is there actually a way to repair, let's say, this broken computation? I mean, what I probably intuitively would expect is to have a data set, a series, sorry, with 10 associated to Ali. Who cares if Ali was not in the second series? It was in the first, so at least give me the value it had in the first series. It appears natural, okay? So is there a way to repair this broken computation? Well, yes. The way to repair the broken computation is do not use the symbol, do not use the plus, do not use the minus, do not use the slash for the division, do not use the asterisk for the multiplication, but use the proper method. These methods give you the chance to tell Pandas how to handle missing data or how to handle mismatches into the index of the series. So, for instance, by doing this, credit 1, add credit 2, and fill values with 0, we actually get what we wanted to get. Because the way it works is that take the first series, credit 1, add the second series. If you don't find a match between the index, so the resulting value will be NaN, replace that value with 0. So what actually happens is that I take my first credit, I have Ali, value is 10, I look into the other series, I don't find Ali, I don't put an NaN, which will result in NaN plus 10 NaN. I put 0, 10 plus 0, 10. So that's why it is usually correct to rely on specific operations, because otherwise NaN values spread very quickly in a way that doesn't seem really intuitive for us. So be careful when you have missing data and you want to do some calculation. Yep.
The series, I mean, in credit 1 it was mentioned like Ali comes first and then Marco and then Elia.
Yeah.
When we are doing an add operation, why the sequence changed?
Because basically the sequence depends on some inner parameter of Pandas, so it can change. If you want to preserve some sort of order, you need to tell Pandas. So in this case, we didn't really care about the order, but if you care, you need to specify additional parameters to the operation. For instance, the add operation or the plus, you can't actually. So for instance, the add operation to preserve some sort of order. Okay. Otherwise, the order can be randomly, let's say, scrambled. Okay, that can happen. But you have some parameter to preserve the order of the operation, or to reorder the index in a given way afterwards the operation has been made. You can do that. And an additional, actually the last one, so related reason for using series over, for instance, lists is that you, for free, you get many operations already made for you. And a quick glance at some of the many operations you have already implemented in Pandas on series is by using the method describe. If you have a Pandas series and you invoke method describe on the series, you immediately get a quick overview of some statistical measures about your series. So let's remember that our reference series is credit total, which is this one. So Ali 10, Elia 15, Marco 10, Paolo 33, Sarah 7. If we ask for this quick overview of the statistics, you immediately have how many values are in the series, the mean of the series, the standard deviation, the minimum value, the maximum value, and 3 percentiers. Okay? That's simply a quick overview of your data that can help. And then obviously you can also have individual methods. Okay, sum immediately gives you the sum, and then you can have all what you want to expect. So you can have, let's credit total dot. You can have the minimum value, which is 10. Let me check. Why do we have? Let's do this. Okay. We modified something probably because the sum is 10, but shouldn't be. So probably we modified something by accident. Yeah, the total cannot be. So let me check. Because we didn't execute this probably. Okay, now the total is correct. And many other operations. Okay, so you can have, I don't know, credit total, and we can have the absolute values. We can add something. The value of the index corresponding to the maximum value, argmax instead of max. Let's check. What does argmax tell to us? Three. What's 3? Is the third position in our series. Let's look at the original series. Position 0, position 1, position 2, position 3. Yes, it's correct. Position 3 is where the maximum value is. And lots of stuff, okay? You can do easily with series and you cannot do as easily with lists. Then, the second data structure that Pandas gave us is a data frame, which is simply a collection of series. When you look at a data frame, at a Pandas data frame, think about many series, all one next to each other. So with a series, you have one index and one list of values. With a data frame, you have one index, but multiple lists of values. So actually, a data frame is a table.